would like to present an excerpt of our recent work which focuses on the screening of bioactive wood extracts. In particular, we were looking into the extractives of tropical species, of which some are known to have especially high shares of extractives, and contain biochemically interesting and partly unknown substances which could play an essential part in the resistance of the wood species against the attack and decomposition by microorganisms. Wood extractives consist of a great variety of components which can be extremely diverse, and the analysis of these extractive cocktails is often time-consuming and in need of sophisticated laboratory equipment, especially when we focus on very polar or high molecular components. And even if much progress has been made in the recent years in developing powerful analytical methods, a bioassay-guided fractionation can still be helpful to focus the analytical efforts on the key bioactive substances. So as the aim of our project, we want to provide a rapid method to evaluate the bioactive components by using the Basidiomycetes, Trametes versicolor and Rhodonia placenta in a bioassay. Conventional bioassay methods are mostly designed for bacteria, yeast or spore-producing fungi, and that is the problem. The methods cannot be readily adapted to Basidiomycete fungi, which are commonly used for the respective durability tests. Gaining spores from those fungi in a laboratory environment is difficult, and the work with hyphae is still common in many laboratories. Therefore, we combined two already established methods to one. The agar overlay method, which means using seeded media and apply it onto a preparative TLC plate, which contains the compounds of interest, and a hyphae agar, where the hyphae are mixed into molten agar. And to make the growth of the hyphae more visible, we added the viability stain tiered cellular blue. The mixed and colored hyphae flocks on the hyphae agar can be seen here on this picture. This idea led to the following key questions. Firstly, is the hyphae agar applicable to the TLC plate? Secondly, is an evaluation of the fungal inhibition possible? In particular, do the homogenized cultures recover fast enough once they are applied onto the plate? Does the viability stain improve the visibility of the fungal growth and therefore enhance the determination of the bioactivity? And thirdly, can the inhibiting compounds be assigned to the bioactivity zones? In the first step, we spot the extract onto the TLC and develop it in 2 dimensions with an appropriate solvent. Then the eluent is evaporated from the plate and the plate is assembled to a template form. Afterwards, the hyphae agar is poured over the plate. The hyphae agar is basically a culture which is grown in malt extract bouillon in the first place and then homogenized and mixed into warm PD agar. After drying for a minute, the plate is stored in a bioassay dish and incubated. And after approximately 8 days, we have a colored plate and can observe zones of antifungal bioactivity. To locate the compounds of interest on a simultaneously developed plate, we compare the 2 plates, and these corresponding spots were scratched off and analyzed by GCMS. Now I would like to show you one set of our experiments as an example. These are plates with extractives of Astronium graveolens on them. The plates with the acetone extractives on it are the 2 on the upper part, and the 2 down here contain the methanol extractives. The plates on the left-hand side are covered with agar seeded with Trametes versicolor, and the ones on the right-hand side are seeded with Rhodonia placenta. As you can clearly see, there are zones that are not colored. There was no interaction of the living hyphae cells with the tiered cellular blue, so we can determine the region where the fungi is in direct contact with the compound. The red-brownish spots here and here are colored by the extract itself. As examples of detected compounds in the bioactivity zones, we have 2 prominent representatives. Firstly, catechin in zone D of the acetone extract, and secondly, gallic acid in zone E of the methanol extract. Both findings can be rated as a proof of principle because both compounds are known to be fungicidal. So what have we learned? The hyphae agar is applicable to the TLC plate. It forms a stable and gelatinous layer on the glass plate. A template is helpful to form an homogeneous layer. The homogenized cultures recover fast enough, and the usage of a viability stain provides a good basis to evaluate the fungal inhibition. The inhibiting compounds can be assigned to the bioactivity zones. A direct inhibition of the extract on the activity of the fungi can be determined. So we can say this technique is a straightforward direct method that provides insight into an unknown extract and offers a rapid pre-selection of noticeable bioactive target substances. Thank you for your attention.